This is Sung from Sky Academy, and we've been looking up until now at linear functions, and we've been working our way through the topic. We are now at the point where we can just kind of wrap things up, and I thought I would make this episode as like a summary of everything that we've done in the course to date. So on the wall behind me, I've got all the information that we've been doing in all the previous episodes in this topic. So let me just turn around and I'll give you the opportunity to see all of that in action. So let me stand to the side, take it all in, alright, and then I'll quickly go through what it is that we've done, okay? So we've looked at all the formula, okay? So for example, some of the formulae that we've looked at include the midpoint formula, which is x1 plus x2 on 2, y1 plus y2 over 2. The distance formula, which is really just a variation of Pythagoras' theorem, which is d equals to the square root of x2 minus x1 squared plus y2 minus y1 all squared. The gradient formula, which of course is rise over run, or another way of expressing rise over run is the change in the y coordinates over the change in the x coordinates, which is y2 minus y1 over x2 minus x1. Now, if you recall parallel lines, lines are parallel where the gradients are equal. Lines are perpendicular where the gradients multiply to give minus 1, or another way of saying they multiply to give minus 1 is that one gradient is the negative reciprocal of the other. We learnt concurrent lines, where any line that passes through a common point between two lines is given by the formula of the first line plus some constant of, times the second line added to it. Okay, so L1 plus K over L1 plus K times L2, okay? Or another way of doing that is to express the lines in terms of their general form, which is AX plus BY plus C. So in this case, we've got A1X, B1Y plus C, 1 meaning the first line, plus some constant times A2X plus B2Y plus C, yeah? Where L1 and L2 are the two lines that will have the common point of intersection to some third line, okay? And then the other formula that we went through was the perpendicular distance formula, which is given by D is equal to the absolute value of A x1 plus B y1 plus C all over the square root of A squared plus B squared, which is where A, B and C are the coefficients and the constant term in the line expressed in general form, and x1 and y1 is the other coordinates of the point. Okay, so we went through those formula. We also went through the different forms of a straight line, the gradient intercept form, which is y equals mx plus b, the point gradient form, which is y minus y1 equals to m outside of x minus x1, the two-point form, which is exactly the same as the point gradient form, except that the m, we substituted the formula for the gradient for m. Okay, so it's y minus y1 equals to y2 minus y1 over x2 minus x1, all in brackets, times, in brackets, x minus x1. The general form, which is ax plus by plus c, and what you need to do is be able to move between the general form and the gradient intercept form. Okay, transposing the equations from one to the other, making y the subject of the formula when you've got the general form, and then bringing all the terms over to the other side when we're converting to the general form. And to understand that this is better for algebra, this is better for graphing. Okay, and then you've got horizontal lines and vertical lines, y equals some constant, x equals some constant. Okay. And then we ended off with two other topics, or two other lessons or episodes, or parts within this topic. Points of intersection, which are solved algebraically by simultaneous equations and solved graphically by graphing the two lines and seeing where they intersect. But in terms of simultaneous equations, there's two methods. There's the elimination method and there's the substitution method. And finally, we went through regions, which are expressed by an inequation or an inequality. And we looked at the difference between a line versus a region, where you've got an equal sign or an inequality sign. We looked at the difference between greater than or less than, and greater than or equal to or less than or equal to, where in this case you've got broken lines, in this case you've got unbroken lines. And then we also looked at when combining regions, the difference between the word and the difference between the word or. So for example, and is where you have an overlap, okay, and you look at the overlap, whereas or, you're looking at combining the total region in one with the total region in the other and seeing where we're all looking at all of the region that's covered by the overlap, okay, by combining the two functions. Okay, so let me just stand to the side so that you can have a good look. But in the meantime, I just want to thank you for watching the topic on linear equations, and I hope that it helps you out. Have fun solving questions now. All right, let me stand to the side. Bye.